Alright, this is section 6.5. We're talking about logarithmic properties. So the first one we're going to talk about is the product rule for logs. So what you're going to do here is, if you have log of base b, and inside the parentheses you have m times n, well then you can break that apart and have log of base b of m plus log of base b of n. And that's just to make sure, you got to make sure that b is greater than 0. Okay? Now let's look at this one right here. Notice I've got log base 3 of 30x times 3x plus 4. So I'm going to separate those out into 30x plus log of base 3 of 3x plus 4. And that's it. So we expanded this log right here to this. Now the quotient rule, this, if you have log of base b of m divided by n, well then you can expand that out to log of base b of m minus log of base b of n. So like this one, now notice we got two things going on. We've got two things multiplied together, and we got division. So first off, let's do log of 2 of this entire thing right here, 15x x minus 1 minus log of 2, 3x plus 4, 2 minus x. And then inside this one, we have two things multiplied together. So that would be log base 2 of 15 plus log base 2 of x minus 1 minus log, and this is going to be minus this whole thing, 2 of 3x plus 4 plus log of base 2 of 2 minus x. Okay, now I have to distribute this negative to both of those. So we have log base 2 of 15x plus log of base 2 of x minus 1 minus log of base 2 of 3x plus 4 minus log of base 2 of 2 minus x. So this is the expanded version of this right here. And then we have something called the power rule. So if we have log of base b of m raised to n, then what we're going to do is we're going to take that n and move it to the front. So now it's n times log of base b of m. So like this one, all I'm going to do is move that 2 to the front, and that's it. Now sometimes we need to rewrite this to where we have an exponent. So we can write 1 over x squared as x raised to negative 2, and then expand that to negative 2 natural log of x. Okay? Now this one, we need to rewrite this as not the square root of x, but x raised to 1/2. So this would be 1/2 log of x. Okay, now this one, first off, I have two things multiplied together. So it's going to be the natural log of x plus the natural log of the square root of x over 1 minus x. Then I need to deal with this one right here, and I'm going to go ahead and change it to being raised to 1/2. So this whole thing being raised to 1/2, and let me move it closer. Okay, so I can go ahead and move the exponent to the front. Okay, and now I have x divided by 1 minus x, so this will be the natural log of x, plus 1/2 natural log of x, and this half is times both of these, minus the natural log of 1 minus x. Okay, so we could write it as natural log of x plus 1/2 natural log of x minus 1/2 natural log of 1 minus x. And this would be the expanded version of this natural log. Okay, so look at this one right here. Now we're going to go opposite here. We're going to condense this down. So notice, number 1, this is log of base 3, log of base 3, log of base 3. So I can combine these. They all have to have the same base. If they have different bases, say if this one was a 2 right here, well, I could combine these two, but I couldn't combine all of them together. They have to have the same base. Okay, so I have a addition sign between these. So that means I'm going to have log of base 3, and that's going to be 5 times 8. We'll go ahead and write log of base 3 of 2. Okay, so we'll go ahead and write log of base 3. That's going to be 40 minus log of base 3 of 2. Okay, well now I have two things subtracted from each other. So that's going to be log of base 3, 40, divided by 2. So log of base 3, and that's going to be 20. And that will be my final answer. Okay, let's look at this one. Log of base 2, log of base 2, log of base 2. So I can combine these. Okay, so first off, I'm going to deal with the numbers in front, and I'm going to make those exponents. So we got log of base 2 of x squared plus log of base 2, x minus 1 raised to a half, minus log of base 2, and this is going to be x plus 3 squared, and the whole thing raised to 3. So log of base 2, x squared plus log of base 2. I'm going to write this as the square root of x minus 1 minus log of base 2. Okay, an exponent raised to another exponent means we're going to multiply. So this would be x plus 3. 2 times 3 is 6. Okay, well now I'm going to multiply things together and divide. So we've got log of base 2 would be x squared times the square root of x minus 1. And then we'll make that just a little bit bigger. We'll go ahead and divide the x plus 3 raised to 6. So this is the condensed version of this log over here. Then let's look at this one. Notice 4 is multiplied times the entire thing. It's got parentheses here and here. So we're going to leave 4 on the outside, and then once we have all the logs put together, then we'll reintroduce 4. Okay, so I'm going to go ahead and do log, and all of these are base 10. These right here are added. This is subtracted, so we have x times x plus 5 over 2x plus 3. And then that 4 can, well, go ahead and rewrite this, can become an exponent like this. And now this is the condensed version. Now let's talk about the change of base formula. So on your calculator you have natural log and you have log. So that would be base 10 and base e. But we don't have a calculator function for, say, log of base 2, 3, 4, 5. So in order to use this on our calculator, we can use the change of base formula. So if we have log of base b of m, where n is not 1 and b is not 1, and m, b, and n are all positive real numbers, then what we can do is we can take the log of base n of m, and usually we would pick either 10 or e, divided by the log of base n of b. Okay, so here would be using base E, and this would be using base 10. So either one, it doesn't matter. You can use both and it'll work out the same way. So let's look at this. Log of base 5 of 3. And we need to evaluate this using our calculator, and we're going to round to 2 decimal places. So I'm going to use the change of base formula. So either one. The thing to note is the base goes on the bottom. So we have log of 3 divided by log of 5, or we'll do a natural log of 3 over natural log of 5. Okay, so we've got 3 log divided by 5 log, and that gives us 0.682, so 0.68. Okay, so this one's 0.68. If we go back and we use natural logs, so 3 natural logs divided by 5 natural logs, that gives me the same thing, 0.682, so that would be 0.68 as our final answer. And then this will do the same thing with this one right here, so base 2 of 10. So we'll look at log of 10 divided by log of 2, and we'll also look at natural log of 10 divided by natural log of 2. Okay, so let me just pull my calculator up. Okay, so 10 log divided by 2 log, 3.321. Okay, so 3.32. And then we'll try natural logs. So 10 natural log divided by 2 natural log, 3.32 again. Okay, so that's just to show you it doesn't matter which one you use, log with base 10 or log of base E, which is natural log, it'll come out to the same answer.